Okay guys, hello and welcome back to another episode of COVID Chemistry. Today we're looking at the topic of quantitative chemistry, basically calculations in chemistry. There's going to be quite a few lessons in this quite advanced topic, some nice simple calculations today, and then we're going to get a little bit more complicated within the next few lessons. So we have a template on the board that we're going to be working from, so I'm going to jump out of the video. Feel free to pause the video right now, then I will jump back in so we can start the lesson. Okay. Okay, so let's begin our lesson. We have a layout here, 1, 2, and 3. You've probably seen where the lesson is going already if you've done your layout. We're going to be looking at some information from carbon, nitrogen, oxygen, and magnesium. We're then going to make some definitions for what we say the AR and the MR. Then we're going to be making some calculations from our compounds here. You'll have a task to complete, and then we're going to be doing some past paper questions. Okay, so our first task, what we want to be doing, you might want to have a periodic table in front of you. If you do not have one, that is okay. You can find them on Google Images, but we will work together. Okay, so chemical symbol C, atomic number 6, and atomic mass of 12. So chemical symbol C of carbon, hopefully we've got that one. We have a small number here that we call our atomic number, and our big number that we call our atomic mass. Just so you know what we're going to do, we're going to identify our number of protons, our number of electrons, and our number of neutrons. And then next we're going to reflect on some previous work we've done with our atomic structure that is going to incorporate our information that we have extracted from our elements here. So each element or each atom I'm going to say here is made up of 3 particles. We have our protons that are positively charged. We have our electrons which are negatively charged, and our neutrons which have a neutral charge. We can take information from each element within the periodic table to identify the number of protons, electrons, and neutrons. So how do we do this? We have our atomic number, and our atomic number, a small number, is going to tell us the number of protons that we have. So let's keep it in line, makes it nice and simple. So the number of protons for carbon is 6. The number of electrons is equal to the number of protons, 6 again. And the number of neutrons, just remember this calculation, neutrons is big number minus a small number. Let's improve that terminology. The atomic mass minus the atomic number. It's not a difficult calculation. 12 minus 6 is giving us 6, okay? Box next to it, we're going to draw the atomic structure. This is a reflection on previous work that we've done, and you've probably done it in the class. We will make sure we are happy with this. So our atomic structure, in the center, we're going to have our nucleus. In the nucleus lives our positively charged protons and our neutrons. How many do we have? Let's just transfer our information across. So protons, 6. Neutrons, 6, okay. Number of electrons, getting a bit more technical now. We need to put our first shell around here. In our first shell, we can have 2 electrons here. And in our second shell, we can have a maximum of 8. But we don't need 8 because we can see we have 1, 2, 3, 4, 5, 6. So we just need 4 more electrons. 1, 2, 3, 4. Nice and simple. Okay, let's continue then. Nitrogen, let's have a look. Protons, positively charged. Electrons, negatively charged. Neutrons, no, or a neutral charge. What do we have? So let's just work across. It makes it nice and easy. Atomic number 7 tells us the number of protons. The number of electrons, they are equal to the number of protons, 7. And our number of neutrons, that trick we said before, big number minus small number, atomic mass minus atomic number is giving us 7. I'm just going to pre-warn you guys, don't always just presume that we're having the same numbers of protons, electrons and neutrons. Chlorine is a prime example here where we have a different number. So it's always important in your exam, just be making these calculations, don't just presume that we're always the same. Oxygen, okay, protons positively charged, let's follow these good habits, identify the charges upon these particles. Electrons negatively charged, and we have our neutrons. Yes, nice and simple, 8, 16 minus 8, 8. So there we see this pattern. For a lot of elements it is true, but we're always checking back. Magnesium, okay, positively charged protons, negatively charged electrons, neutrally charged neutrons equals, let's have a look, let's put this information in. Electrons equals protons, neutrons, big number, small number, mass minus atomic number is giving us 12. So that's nice and easy. Your first extension task that I would like you to complete is just reflect on your knowledge of how we can draw these atomic structures. Identify the number of protons and neutrons in your nucleus, then identify your shells and the number of electrons here. So we're doing that for nitrogen, for oxygen, and for magnesium. Okay, now on to our next task. We want 2 definitions we want to identify. We have what we call our AR and what we call our MR. So our AR, please make a note of this, is what we call our relative atomic mass, okay? And chemists have identified our relative atomic mass in relation to carbon 12. Tricky definition, please do some further reading around this. But for the time being, relative atomic mass for our AR. In your exam, they might refer to this term AR. We are just looking at the mass of the element, but they say in relation to carbon 12. So the AR of oxygen, 16. The AR of nitrogen, 14. So we can see this pattern, how they're starting to develop this advanced terminology. Our MR, our relative formula mass. So how is that linked to our AR? So let's have a look. So we could have a situation where we have an atom. I'm going to name it atom A, and I'm going to say we have the AR here. Bonding is taking place, a chemical reaction has happened. We have an AR of B, and that is going to give us what we have here, our MR. So the addition of the AR, the relative atomic masses of what is being joined together to form our MR. So I'm just going to put a note here. We refer to as the relative formula mass. Okay, nice and simple. Let's use this information we have here to put it in a practical setting and some data we need to know. So, relative formula mass for MgO, magnesium oxide. Our first one, nice and simple. We have 1 magnesium and 1 oxygen. Let's just follow this same template, nice and basic so far. We don't want to make life difficult. So, let's just put these circles in. We have atom A, magnesium, the mass, okay, so the AR, 24. Let's put that in. And what are we adding that to? Our oxygen. Let's take this, our AR of oxygen, 16, and that is going to give us our MR. And what is our MR? 24 plus 16. Perfect, that is giving us our MR for magnesium oxide of 40. Oh, nice and simple. It's only simple if we follow this simple template and take our time. Next one, a little bit more difficult. Don't fall into the trap of just having 1 oxygen. We have carbon dioxide. We have 2 oxygens here. Let's just do the same thing though. So, AR, of carbon, we have 12. That's nice and simple. Plus, we have 2 lots of oxygen. Let's put this in. So our oxygen, 16. 16. Oh, a little bit more tricky. 16 and 16 is 32. And 12 is 44. So let's have here, we have our MR of carbon dioxide is 44, like this. Let me just improve my answer. What have we calculated here? 40 could be anything. Is it 40 potatoes, 40 bananas? No, that's always identifying what we're calculating. Okay, so your next task, bit of a recap. First task, you should have your atomic structures done now. Your second task, I would like you to reflect on this topic of bonding. We can see how everything is joined together in chemistry now. Draw out the bonding for magnesium oxide. You'll have to draw your atomic structure. You'll have to see what is taking place. Are we sharing? Are we donating? Are we gaining electrons? Identify the type of bonding. Is it ionic? Is it covalent? If you've not watched these videos yet, please just reflect back on the videos and this will help you. So we want the bonding for magnesium oxide and this bonding for carbon dioxide to oxygen. It's very important to remember. Okay, task 1 done, task 2 done, task 3, wow, we're doing so well at the moment. Okay, tricky term we want to be able to define. It's not the animal. The mole in chemistry, the definition for this is the amount of substance. And 1 mole is the relative, I've been lazy, I can fit it in, formula mass in grams. 1 mole is the relative formula mass in grams. Okay, so how do we calculate the number of moles then? We need to make a note of this equation because we want to apply this knowledge into 2 past paper questions. Very simple one, a little bit more advanced. So we're probably looking at maybe a 1 mark question and a 2 or 3 mark question. Let's put it as a 2 marks. We need to do a bit of a range. So, how many moles are there in 42 grams of carbon? How many moles? Well, that's nice. We just made a note of how we can calculate number of moles, and we have the mass of the element divided by the AR here. So we can take this information from the question. Mass of the element, okay, 42 grams, so that's great. So let's put this information in. 42 divided by the AR, okay? AR, relative atomic mass of carbon. Let's have a look. There we go, 12. Nice and simple. 42 divided by 12. Ooh, calculators out loud. I think we need to. 12, 24, 36. That's 6. Okay, that's nice. 3.5. What were they asking? How many moles? So within 42 grams of carbon, there are 3.5 moles. That was simple. Let's pick up all these marks in our exam. Our second one, and my task to you, is to use our mass, moles, relative atomic mass, relative formula mass triangle. Let's make a little note of this. N, don't be confused by this. N is just referred to as the moles. So we know how to rearrange our triangles when we're using this. If we have the mass, we're dividing by the moles, or the AR, or the MR, anything next to each other, we are just simply multiplying. So my question to you to complete is, how much would 0.8 moles of sulfuric acid, this is where you're going to be using your calculations, H2SO4, weigh in grams. So you might need to refer to your periodic table, you might need to use this data here and extract this information to use in your triangle. Okay, thank you for tuning in once again. A lot of work there. If you need to rewind or just watch some things over, that's fine. Go at your own pace. But thank you very much for watching once again.